Queue. A queue is a fundamental data structure that organizes data in a linear order following FIFO principle. During our stat lectures, we had seen about LIFO principle, that was last in, first out. Now we are going to consider FIFO principle, which is first in, first out. So think about any queue that you see in your day-to-day life. Let us say people standing in a ticket counter. So what happens there? Whoever comes first is also the person who gets to go first out of the queue. So this is the FIFO principle. So let us say you have a ticket counter here and there are many people standing here in order to get the ticket, and let us say they are following a queue. Then what happens? The first person, whenever the counter opens, he'll get the ticket. He can go out of the queue. The second person will move forward. He will get the ticket. Then he'll move out of the queue and so on. And what happens if any new person comes in? He's only allowed to stand in the rear of the queue. So he has to come and stand in the back of everyone. So this is how a queue works in your day-to-day life. And the same is what gets implemented in data structures. So let us learn about queue data structure. So coming to queue, there are two primary operations. First one is enqueue. Enqueue is adding a new element into the queue. And second one is dequeue. Dequeue means removing an element out of the queue. So these are the two major operations you have. And as you know, where will enqueue happen? Enqueue will always happen at the rear of the queue. So let us say this is a queue. So this is the front, this is the rear. So enqueue means adding a new element always happens at the end of the queue. And what about dequeue? If you want to remove an element, always remove from the front of the queue. So this is the basic principle you have to follow whenever you are doing queue operations. You should always maintain the queue structure. So, in order to do this, you can have two implementations. One is array implementation, other one is linked list implementation. But in both the implementations, when it is a queue, you have to always keep a front pointer and a rear pointer, because these two are the pointers which will always keep track of the positions at which you have to enqueue and dequeue. So, queue have certain varieties, so we'll just go through about all the varieties, and then in the coming lectures we'll deep dive into each of those varieties. Okay, so now you got a basic understanding of the queue data structure, what it is supposed to do. There are few varieties of queues that we generally have whenever we are dealing with data structures. The first one is the standard queue that we already discussed, that you generally have something that you normally see in day-to-day life. Any new additions are to be done at the rear, and anyone who has to go out from the queue has to go from the front end. This is how general queue works. So that is a standard queue. Second thing is a circular queue. A circular queue. So when you learn about circular queue, it will be clear that especially when coming to array implementation of the queue, this circular structure of the queue will give you a lot of advantages. Your time will be saved compared to the normal standard queue. So here the only difference is the end of the queue, the rear pointer, it can wrap around to the front once it reaches the end of memory. That is, in case, let's say it is an array, you allocated some array. Whenever the memory gets exhausted, it can come back to the front. So we'll learn about this in detail. We'll learn in a circular queue lecture. The third one is a priority queue. Let us say you are following a queue at some ticket counter. Let us say some celebrity came into this. What will happen? A lot of people are standing in the queue. They're all standing there, let us say, for some time for now. A new person comes in. This person, let us say, is a celebrity. This is a celebrity. When the celebrity comes in, he'll skip the queue and directly go to the front, and he'll directly get the ticket from here. So this is how it happens in normal life, and the same thing is implemented as priority queue. So in priority queue, it's not just the FIFO principle, but also about the priority of that element. Whichever element has the highest priority always gets to go out first. So we'll learn about this as well when we reach the fourth one. Say double-ended queue. Double-ended queue. In double-ended queue, you are allowed to insert as well as remove element from both the ends. So when we learned about queue, we said that insertion always happens at the rear, and any sort of removal, a dequeue, always happens at the front. But in case of double-ended queue, it can happen at both ends. So before we conclude this lecture, one more thing. What are the applications of queues? In what sort of a program or a problem you may want to use queues? So whenever you learn about data structures, it's important to understand where to use it. In what sort of an application should you store data in this particular data structure? You should always know that. So coming to queues, one is, let us say, in a task scheduling. If you want to schedule many tasks, you have task 1, task 2, task 3, task 4, so on coming up. And whichever task came first needs to get the first priority. It should be completed. Then you will take up the second task, then the third task, then the fourth, and so on. So in this sort of a case, you will keep the tasks in the queue. Any new incoming task will be added at the rear of the queue. And whenever your first job is completed, you will take the next task from the front of the queue. So this is how you do task scheduling. So it's also using a breadth first search. We'll get into breadth first search, then it will be clear. Then you have, well, let us say you have any real world scenario where you have to maintain a queue. In all those scenarios, you will use the queue data structure. So something like, let's say, online ticket booking. If you want to implement online ticket booking, whichever request came first should be entertained first. So you implement a queue here. Okay, so let us go into the next few lectures on queue about how exactly enqueue is implemented, how exactly dequeue is implemented, what about circular queues, priority queues, double-ended queues. We'll learn about all these. Okay.